In this video, I am going to walk you through the solution to a work rate exercise. These are commonly found in algebra books, but also appear on the math portion of the SAT. So before we do any mathematics, let's take a look at a picture to be sure we know what we are being asked to find. So imagine the following situation. There's a wall. And the wall is to be painted. And say there's one person painting from one end, and another person painting from this end, as follows. And one person may paint this portion while this person paints twice as fast and paints that portion. Okay, maybe this takes 1 hour. Okay, so maybe 1 hour has elapsed on the clock, and this person paints another portion, and this person paints two more portions, like this. Now 2 hours have passed on our little clock. And then the next hour passes and this person paints this much and this person paints a little more. Okay, so this is the general setup here. We may say then the following. Let's draw another wall and we will make it even simpler. You have two people and one person. Let's divide the wall into equal columns. Say one person can paint one of these columns every 1 hour, and another person can also paint one of these columns every 1 hour. Now each little column here is 1, 2, 3, 4, 5, 6, 7, 8. So this person can paint 1/8 of the wall, and this person can paint 1/8 of the wall. Okay, so this is the general setup here. Then this number here, the 1/8, is the rate of work of this first person, and then 1/8 is the rate of work of the second person. And at the end of the job, they have painted the entire wall. As all the time has passed, they finished the job. So this is the equation that we would actually write to represent the situation. We can say the first person's rate of work, which is 1/8, and then the second person's rate of work, which is the 1/8. You would multiply by t and add to it t, multiplying 1/8. This equals 1. So this will be the equation that would flow from this setup. And many times what you will see is a table that has the following appearance. For example, you might say here person 1, person 2. This would be the rate of work, the rate. I'll just write here the rate. This would be the time taken. We'll call that t. And this is the part contributed. Okay. Here we are. So here's our table. So person 1 has a rate of work, say, of 1/8. Okay. So you can think of this either as 1/8 of the wall, or you can think of it as one wall every 8 hours. It has the same meaning. Same with the second person. The time they work together is unknown, so what used to be presented, of course, is the variable t. Within this period of t hours, the person 1 here contributes 1/8 times t. Person 2 within the period of t hours also contributes 1/8 times t. And at the end of the whole job, what we have is the part contributed by the first plus the part contributed by the second equals to 1, or 100% if you like. You could also do this by dividing the wall into 100 pieces and then taking a look at the exercise in terms of percentages and percents. So now once we arrive at this equation, the question is, how do we solve it? So let's take a look at the procedure. First of all, notice that we have the same denominators in this case, so we can simply add these as 2/8 t equals 1. Now we can multiply both sides by the reciprocal of 2 halves. So, I'm sorry, 2 eighths, so that's 8 over 2, 8 over 2. Then you cancel the 8 and the 2, and all that remains is t equals 8 over 2, which of course we know is the number 4. So this means that the two people working together take 4 hours to complete the task. Okay? And now, is this reasonable? It absolutely is. Okay? Let's review. I will draw the wall again. 1, 2, 3, 4, 5, 6, 7, 8. A wall that we can divide easily into 8 columns. Okay? And 1 hour has passed. This person has painted this much, and this person has painted another 1/8. This is 1 hour into the job. Then another hour into the job. Now imagine it's 2 o'clock. This person has painted 1/8, and this person has painted 1/8. Then another hour into the job, so now let's imagine it's 3 o'clock. This person has painted 1/8, and this person has painted 1/8. And lastly, at 4 o'clock, this person has painted 1/8, this person has painted the other 1/8, and you see that the whole wall has been painted, so the whole job is completed, and this has really taken 4 hours if you take a very sequential step-by-step, by hour approach. Okay? So one more time to review. What we have is usually a task, and I am using the example of painting a wall because that is easy to visualize. But these apply, for example, to imagine 2 copiers printing a job together, or anything of that nature. Okay, 2 electricians working on a house together. Not just 2, it could be any number, but that's for another video. So now in my case, I am using a wall because that is easy to visualize. You see it looks like this. You have 2 people. In this case, I've given them the same rates of work for the sake of simplicity. This person completes 1/8 every 1 hour. This person completes 1/8 every 1 hour. So we set up a little table like this to organize our work. The rate of work of the first times the time is the part contributed by the first. The rate of work of the second times the time is the part contributed by the second. This gives rise to the equation here. So then 1/8 t plus 1/8 t is 2/8 t. You multiply by 8 over 2 on both sides. Cancel the 8's, cancel the 2's, and all that remains is t equals 8 over 2, which is also the number 4. So this 4 tells us that the 2 people working together take 4 hours to complete the job. And here you can also take a sequential by hour approach to convince yourself that this number actually physically corresponds to what would happen if you had 2 people painting a wall that has been divided into 8's. So thank you for watching.